Alright, so example 6.1. Oh, it's a little bit laggy.
It doesn't want to do a million frames per second because it's got right disk.
That is true, and it's hard disk, so it's really bad. Okay,
You're recording.
I am, yes. Just to see how it goes. So we'll try it now. We've got A there, and we've got B there, and we've got C there. The question says express this vector in terms of A and B. So what's going on here? I'm asking you to express one vector in the form of two other vectors. Express 6 in the form of 3. How would I do that? Well, 2 lots of 3 is 6. So I'm asking you how many lots of A plus how many lots of B is going to give you C. Now these two letters are lambda and mu. There are scalars. The scalars. So something times by vector A plus something times vector B will have to give me vector C. I don't care what number it is, it's going to have to equal. So I'm going to rewrite this with the numbers in there. Before I move on, any questions? Please stop me if it doesn't make sense. Okay, so the I component, let's just hone in on the I component. 6 equals something times 2 plus something times 4. So these two things are numbers. So 6 equals a number times 2 plus another number times 4. And the vertical component, negative 4 equals 3 times a number, which we don't know yet. But it's the same as that number. It has to be. Why does it have to be the same? Because these are all from vector A. Plus negative mu. We'll just write negative. Alright, so, what are we looking at now? We're looking at some simultaneous equations. Now we can use the class pad to solve it. Everybody know how to do that?
Yes.
If not, I can show you later. But if this was in the calc free section, how now? Says the brown cow, right? We can use elimination. We can use elimination. So I'm going to use elimination. I'm going to go 6. So I'm going to I'm going to call this equation 1. I'm going to call this equation 2. Okay. 6 equals 2 lambda plus 4 mu. And then I'm going to go 4 times equation 2. And I'm going to add them. And I'll show you why.
But why did you write equation 1?
So this is equation 1 here.
Yeah, but why did you write it?
Because to use the method of elimination, we have to try and remove variables by adding or subtracting the whole equation.
Yes.
So I'm going to times equation 2 by 4. And that's what I get. Now, do you see why I add them? Because 4 mu, take 4 mu, is 0, which we love. 6 add negative 16 is negative 10. 2 add 12 is 14. Aha! We've already eliminated one of those variables, hence the use of elimination. Okay, so now we know lambda is going to be negative 5 over 7. That's our exact value. And then we just have to substitute it into any one of those to get mu. So let's use equation 1. We have 6 equals negative 16 over 7 plus 4 mu. Yes, you can do 1 or 2. I'm just doing 1 because that's what I did last night. So, sorry. Negative 10. Yes. Negative 10 over 7 because it's 2 times lambda over here. I know. Hold on, let me keep going. Alright, so let's see. So we have that. We're going to now move this over to that side. 6 plus 10 over 7 equals 4 mu. So I've moved this over to that side. Okay, I've put that into one fraction. And I'm going to now divide both sides by 4, which gives me 13 over 7. So I have lambda over here, and I have mu over here. Now I can put C in terms of A and B. So vector C is going to be lambda, which is negative 5 over 7A, vector A, plus 13 over 7, vector B. Now, literally, if you take negative 5 over 7 times 2I plus 3j plus 13 over 7 and multiply it to 4I minus j, you will get 6I minus 4j, which is C. Alright?
That's amazing.
It is very amazing.
Multiply it.
So I'll actually show you. Let's do a little, see, it's actually meant to be a 0.2 there. So you can write that in. Sure, we'll do that. Okay, so now, this is in the book as well, but I thought I'll go through it because it's quite a big question in the book. And I want to make sure that we understand it. So airports A and B are such that AB is this distance away from each other. So notice that this is a distance. Alright? So even though it's in component form, it's a distance.
Yeah.
Your book. I'm trying to find it on my book. Found it, never mind. Okay, so an aircraft needs to be flown directly from A to B, and the aircraft can maintain a speed of 390. So there's a few things I want to highlight here. The speed, the distance, and then there's a wind. Wind is very special, so we're going to go wind in a different color. So let's draw a little diagram of A to B. So that's A. And to B, we know B is going to be here somewhere. Alright. We want to travel across this path here. So where is wind going? Well, the wind is going 30I, 20J. So the wind is going in this sort of direction. The wind's going there. So I know I'm going to have to fly some sort of way this way, so that when the wind pushes me down, when the wind pushes me down, it pushes me to AB. So I'm going to have to fly some sort of point this way, so that when the wind pushes me down, and we know the wind is 30I minus 20J, we're going to end up on the path of A to B. Okay? Now the question says, find in the form AI plus BJ. So we're going to write this in there, AI plus BJ. So this is what we're trying to find. We're trying to find the velocity vector that the pilot should set so that when he takes it off this path, the wind goes and he goes back to AB. Alright, how now? Says the brown cow. Where do we start? We understand the concept? Any questions on what we're doing? Alright, so the resultant of this, okay, the resultant of this has to be multiple of that, because what this is actually the unit vector of AB. This is only 1 kilometer, but we're looking at kilometers per hour. So in 1 kilometer, sorry, in 1 hour, we're going to travel that many kilometers.
Wait, how do you know that though?
Because this is a distance.
Yeah.
This is a speed.
Yeah.
So here's what I'm going to write down now. We got AI plus BJ. That's going to add my wind, because I have to add my vectors. Okay? And that's going to equal a multiple of my distance, because in 1 hour it's that distance, in 2 hours is multiplied by 2. We don't know the time, but we know that it's going to be some sort of scalar multiplied by my distance. Now let's just say that has to be greater than 0. Alright, and now we need to solve for A and B. But then you go, hold the phone, Mr. Prakash, there's A, there's B, and there's this bad boy over here. Right? Not good. How now? Says the brown cow. So we have to find a way to eliminate this lambda, this component here. Well, let's change this around. I'm going to rearrange this equation to AI plus 30I, and then plus BJ minus 20J. And I'll leave that side the same for now. That's vector I. That's also a vector I. So I can actually factorize out I. And I can also factorize out J. Look at this. Almost done. And then over here we have 600 lambda I plus 200 lambda J. Now do you see what's happening here? Can you see it? Something times I has to equal this thing times I. And something times J has to equal that something times J. So here's what...
Brackets are just there to show that.
Sorry?
The brackets are there to show that.
Yes, the brackets are there to show that. Normally we wouldn't write them in. So in other words, A plus 30 has to equal 600 lambda. And also B minus 20 has to equal 200 lambda. How do we get rid of lambda? Can you see a very quick way? We can divide them. We'll call this 1, we'll call this 2, divide 1 by 2. A plus 30 over B take 20 equals 300. Okay.
You move the page.
Sorry about that. Now we're going to now put A in terms of B. I'm going to skip this algebraic manipulation step, but we're going to turn this into A equals something. I'll do it really quickly, but you would get 3B take 90. So this is just moving it around and multiplying it out, and then moving everything over so that A is by itself. Now there's another thing that we know. If you look at the very, very top, it says the aircraft has a speed of 390 kilometers per hour. In other words, the magnitude, what am I doing? The magnitude is 390. So now we've got two equations with A and B that we can solve simultaneously with the CAS, or if we want to do it by hand, we can also do that. We have A squared plus B squared equals the square of 390. Whoops. I'm going to go this way, you can go down. And I'm going to substitute A with that one. So 3B minus 90 squared plus B squared equals 390. And I can solve for B. When I solve for B though, I get two answers. Now you can test this with your class pad, but B is going to give me two answers. It's going to take a while because, yep, we're still going. B is two answers, but normally you would give them both, but it can only be one of them. Which one can it be? Which one does it have to be? Go up to the very, very top direction. Matt already said it. We'll go up to the very, very top and look at your diagram. What value of B does B have to be? It has to be the positive one because it's going upwards. So therefore B can only be, B has to be 150. Alright, and I can solve for A by putting 150 into there. A equals 3 times 150, take 90. A equals 450, take 90. A equals 360. If you have space, go down a little bit, down the page a little bit. Therefore, the velocity is going to be 360I plus 150J.
That's the plane.
So that is the speed of the plane. So the magnitude of this will equal 390, and the direction will allow the wind to push it to on the direct path of A to B. So kind of what we did with chapter 3, where we had winds and or the canoes, currents. Any questions on that? Give me back up. We'll spend tomorrow on 4B as well. Some work time. It's because you're having fun right now.
This is actually the best class so far.
Wow.
Or one of them.
That's a big. That puts a lot of weight on me, Matthew. Now I'm gonna have to live up to it.
This is my best class today.
No, I'm doing
probably.
Thank you.
I'm
Really,
doing
is that a bit less pressure?
Ah, okay. Yes, this is a very specialized class.
You should really stop the recording before I say something I shouldn't do.
Worst possible day. Why is it worst possible day?
Thursdays are the worst day of the week.
Can you stop, you stop the recording so before I say something?
Oh, wow. Cool. Cool soul.
Now,